So this is my model to demonstrate what trail is actually doing. So I've got a pivot on the front that this rod can move around in. And so this is where the pivot is actionable along the plane of the ground. And here I've got the wheel. And where the wheel is where it's basically acting upon the ground and applying its weight with the ground. So if I set to a modest trail of 150 millimeters, you can see that as I move the pivot around, the wheel likes to follow it. Right? And it squeaks. If I've got a big long trail, you can see it becomes even more and more stable, but it gets kind of funny and lethargic. So if I set the trail to a much smaller measure of only 30 millimeters, you can see it is causing the wheel to trail behind the pivot, but it obviously is lacking in stability, and I'm getting some sort of wobbling action. I'm getting the shopping cart effect going. Now, that's with the positive trail. If we look at the negative trail, basically what I'm doing is I'm pushing the wheel in front. And the wheel doesn't want to be in front, it wants to be behind. And as long as I keep everything in line, it doesn't seem to complain about that too much. But it's an unstable situation, and as I push it around and forward, the axle wants to flip around and trail. It doesn't want to be leading, it wants to be trailing. So it tries to flip around backwards. And what that means for your steering is that as you're trying to go straight, the wheel is wanting to swing its way around back, and it's putting energy into keeping it into a turn. And that's not very good. So if I make the positive trail really small, it becomes it becomes pretty obvious what's going on because it can react so fast. And if I try to push on it, it just swings around really unstably. So try to push it and whoop, swings around. So for sure, a positive trail is unstable.